Hello and welcome back to another video. Here we are going to continue with the specimen paper of pure probability and statistics 1, that is paper 5 for this examination from 2020. So here's the question number 4. A petrol station finds that its daily sales in liters are normally distributed with mean 4520 and standard deviation 560. A part is find how many days. If it is how many, we are going to calculate the expectation. How many days of the year? 365 days. Out of 365 days means it's not a leap year. The daily sales can be expected to exceed 3900 liters. So if we take X as the amount or liter of petrol used, so we can see this. They want the expectation for, if it is out of 360, so 365 into the probability of X exceed greater than 3900. And it is, since it is normally distributed, so we can write X as normally distributed with mean 4520 and standard deviation 560. It means mu is 4520 and sigma square, it is variance, so it is sigma square 560. So let's find this probability, and at the last the number of days would be 365 multiplied by its probability. So the probability of X greater than 3900 is going to be, we'll write in the standardized form, and in the standardized form we write Z greater than 3900 minus mean, that is 4520, and whole upon standard deviation, that is 560. So it is square here. So now we will calculate this, and this value is probability of Z greater than, this value is minus 1.107. So it would be easier if we draw the diagram, standard normal distribution graph. This is mean where Z is 0 and it is minus 1.107, so this point would be somewhere here. And since we require the probability greater than, means we require this area. So in these cases we are going to find the corresponding positive value here, which would be of course 1.107, and then the area, corresponding area for this is going to be this. It means this value would be same as phi of 1.107, and we will get this value from the distribution table. So we can see 1.1 and then 0 and then 7 is this. It means 0.8643, and the last two digit will add this 14, means plus 0.0014, and hence the total answer is 7 here, 5 here, 6 and 8. So it is 0.8657, and hence the number of days would be 365 multiplied by this probability 0.8657, which is 315.98. So we can write either 315 days or 316 days. Both are acceptable. So I hope it is clear. Let's discuss the B part of it. The daily sales at another petrol station are X liters, where X is normally distributed again with mean M and standard deviation the same 560. It is given that probability of X greater than 8000 is 0.122. So here this daily sales is given as X. We have a random variable and it is given as normally distribution, so we'll write it as X as normal distribution with parameter. So mean is M here and standard deviation is 560, so variance become the square. So we need to find this probability, so we are going to calculate by using this property. The probability of X greater than 8000 is equals 0.122, and in the standard normal distribution form it is Z greater than 8000 minus M over mu, that sigma, that is going to be 560 here, is equals 0.122. So we can see this probability is 12.2%. So from the diagram it would be very much clear. We are getting more than Z, more than 8000, and this is 12.2%. so we can see from here this mean would be somewhere here and 8000 is somewhere here. That's why the probability of getting more than that is 12.2%, because it is less than 50%. So it means this is going to be a positive quantity. So if it is 12.2%, so we'll get corresponding this value by taking 100 minus 12.2%. So it is 8, 7 and 8. So 87.8%, and this is going to be phi of Z corresponding to this. It means we can write it as 8000 minus M over 560 is phi inverse of, not 12.2%, it is phi inverse of 87.8%. So we can write it as 0.878. So we will get this value from distribution table again, and this value is 1.165 by using the reverse distribution table reversely, so that we can get the value from the probability, we get the Z value. And now we will solve it. So it is 8000, I will multiply by 560 and take it to this side. It is minus 8560 multiplied by 1.165, and this is going to be M. And this value from calculator we can get it as 7347.6. this is the mean, and we can write our answer till 3 significant figures, 7347, so it is 7350. That's the mean of that is the value of M. Let's discuss the next part. Here's the C part. Find the probability that daily sales at this petrol station exceed 8000 liters on fewer than 2 of 6 randomly chosen days. So for first of all, we can see it is 2 out of 6. It is binomial. So for that we require the success probability, and success probability means here the success probability is daily sales exceed 8000, means it is going to be probability of X greater than 8000, and from the previous part we have this probability as 0.122. so Q would be 1 minus 0.122, which is 0.878. Now we will use the probability. It is going to be binomial, that is of course x less than 2 means probability of x equals 0 or probability of x equals 1. So for 0 it is going to be 6c0 p to the power 0 and q to the power 6 plus 6c1 p to the power 1 and q to the power 5. And we have the value 6c1 is 1 and p power 0 is of course 1, so q power 6 means 0.878 to the power 6 plus 6c1 is 6, p is 0.122 and q to the power 5, that is 0.878 to the power 5. Now we will calculate this value, and this value is 0.458 and 6 into 0.122 into 0.878 to the power 5 is 0.3819, so it is till 3 significant figure, it is 382, and we will add them and it is coming 0.8399 and all, and the complete value I have taken, so we can write from here also it is 0.84 because it was 9929 and so on. Correct value, like it was 199, so the correct value till 3 significant figure or like 2 decimal place 2 significant figure, it is 0.84. so that's the probability. I hope it was of some help. Let's discuss the next question now. Here is the question number 5. A fair 6-sided die with faces marked 1, 2, 3, 4, 5, 6 is thrown 90 times. Use an approximation to find the probability that a 3 is obtained fewer than 18 times. So we can think of normal distribution here because they are not talking about any average. So we can approximate this situation by normal distribution. And for normal, since it is binomial, because it is either happening or not happening 3, but we are approximating by normal. So for normal, we require the two parameters, that is mu and sigma square. So for binomial, it is going to mu is going to be n times p, and sigma square is n times p times q. And here getting a 3 probability is 1/6, so mu become 90 multiplied by 1/6, and sigma square would be 90 times 1/6 into not happening, it's 5/6. So we have it now, 15 6 90, and here again 15 5 3 5s are and 3 2s are, so it becomes 25/2, 12.5. So now we have the parameters for normal. We can take it as x, normal distribution, and the question become probability of x less than 18. And now if it is less than 18, we have to use the continuity correction as well, because we are approximating a binomial discrete situation to the continuous. So 18 is going to be here, it is going to be 17.5, and for half ahead it would be 18.5. so the thing is, like, if there is a block of it less than 18 means you are going in this direction, not including 18 means you'll not include the whole bar, so you have to leave this. So the starting would be probability of x less than 17.5, and in the standard normal distribution it would be z is less than 17.5 minus mean is 15 over sigma, that is square root of variance, square root of this is 12.5. And now we will calculate this value, and this value is probability of z less than, it is coming 0.707. and now we will calculate this probability because it is going to be z less than, so it is phi of 0.707, and this value from the distribution table we 0.760 till 3 significant figure, it is 0.760. That's the probability of getting 3 fewer than 18 times. I hope it is clear. Let's discuss the next part. The next part is to justify your use of approximation in part A. So in part A we have seen that binomial is being approximated by normal, and since NP was 90 into 1 by 6 is 15, greater than or equals to 5, which is of course greater than 5, and NPQ again it was 12.5, which is also greater than 5. So we have two conditions, 12, the variance mean and variance both are greater than 5. That's why we can approximate a binomial distribution by the normal distribution. And next one, on another occasion the same die is thrown repeatedly until a 3 is obtained. Find the probability that obtaining a 3 requires fewer than 7 throws. So we are focusing on the first success, it means it is geometric, so we can take this another variable x as geometric distribution with success probability, means getting a 3 is a success for it, means the probability is 1 over 6. So P here is 1 over 6 and failure probability is 1 minus 1 over 6, that is 5 over 6. So this probability becomes, the probability we require is x, this is the number of x, here x is number of throws requires to get the first success. So this probability, this question become x fewer than 7 means less than 7 we require, and we find this probability by taking it as 1 minus probability of throws which are required to get the first success are either 7 or more than 7, and it means that first 6 trials were not success, because it is given that in order to get the first success we require 7 throws, at least 7 throws. So it means all the 6 times it was a failure. So it become 1 minus 5 over 6 to the power 6, and this value is 1 minus 0.33489, so it is going to be 49, I will write, and so on. And when you will subtract this from 1 we will get this value as 0.6651 or till 3 significant figure. That's the answer. I hope it was of some help. So that's it for this video. We'll discuss the last 2 questions in the next video. Till then, thank you so much.